All right, so I'm going to make some analytical and graphical connections between the first, second derivative and the original function. And then you guys are going to do an activity, a quiz trade activity. All right, so we're going to start just by talking about f of x and f prime of x, and then we'll continue that same pattern. We would throw in the second derivative. So if f prime of x is equal to 0 or undefined, that means that we're talking about a critical number. And a critical number has a potential relative maximum or minimum. All right. If f prime of x is positive or greater than 0, then f of x is increasing. If f prime of x is less than 0, then f of x is decreasing. Right. If f prime of x changes from positive to negative, so basically the function is changing from increasing to decreasing, that creates a relative maximum. So f of x has a relative maximum. And then if f prime of x changes from negative to positive, f of x has a relative minimum. Okay, so the relationships between f prime of x and f of x are exactly the same as the relationship between f double prime of x and f prime of x. All right, so if you look at this first column here, it matches this column here where we're talking about the second derivative. So what that means is the f prime of x column should match exactly with the f of x column from the original. So f prime of x and f of x have the exact same relationship as f double prime of x and f prime of x. So if the second derivative is undefined or 0 at x equals a, then f prime of x has a potential relative max or min there at x equals a, just like what we said there, right? If f double prime of x is greater than 0, then f prime of x is increasing, just like we already wrote with the other relationship, right? F second derivative is negative, the first derivative is decreasing. If the second derivative changes from positive to negative, the first derivative has a relative maximum. If the second derivative changes from negative to positive, the first derivative has a relative minimum. All right. And then let's talk about what that means for f of x. All right. So if f double prime, the second derivative, is 0 or undefined at x equals a, what that means for the function, it has a potential point of inflection. Okay, so the relationships between the second derivative and original function have to do with the concavity. So this column should be about concavity, points of inflection. So if f double prime second derivative is positive, then the original function is concave up. If the second derivative is negative, f of x is concave down. If the second derivative changes from positive to negative, that means that the function is changing from concave up to concave down. That means that there is a point of inflection there. So it has a point of inflection. And then same thing on changing from negative to positive. Still changes concavity, still has a point of inflection. Okay. So now we're going to do the quiz trait. It's going to be challenging, but hang in there, you can do it.